So, welcome to a lecture series on database management system. In today's lecture series under database design, we will discuss about the functional dependencies. So, in a relation or in a table, an attribute is said to be dependent on each other. If it uniquely identifies other attribute of the same table, then the attribute is said to be dependent on each other. For example, consider student table with the attributes student name, student ID, and age. Here, student ID is an attribute that is used to uniquely identify the name of the student. Because if we know the roll number or the student ID, we can tell the name corresponding to that particular ID. So this is known as functional dependency. So we can represent this functional dependency as student ID determines student name. In other words, we can say as student name is functionally dependent on student ID. So, how to address this formally is if column A of the table uniquely identifies the column B of the same table, then it can be represented as A determines B, or attribute B is functionally dependent on A. We have four main types of functional dependencies. They are trivial functional dependency, non-trivial functional dependency, multi-value dependency, and transitive dependency. So when it comes to trivial functional dependency, so dependency of an attribute on a set of attribute is known as trivial functional dependency. So we can symbolically represent as A determines B is trivial functional dependency if B is a subset of A. So A determines A and B determines B is also considered as uh, trivial functional dependency and they are self-determinant. For example, consider a student table with two columns, student ID and student name. Here, student ID and student name together can determine student ID. And this particular dependency is called as trivial functional dependency since student ID is considered a subset of student ID and student name. Because if we know the values for student ID and student name, obviously we can find the value for student ID, which is unique. So, also student ID can determine student ID and student name. Student ID and student name can determine student name, which is self-determinant and are also example for trivial functional dependencies. Next, we will see about non-trivial functional dependency. So it is quite opposite to trivial functional dependency where the functional dependency X tends to Y or X determines Y holds true where Y is not a subset of X, then such dependency is called as non-trivial functional dependency. Consider an employee table with three attributes, employee ID, employee name, and address. Here, the following functional dependencies are considered non-trivial. Employee ID can determine employee name, where employee name is not a subset of employee ID. Similarly, employee ID can determine the address of the employee. Here also, employee address is not a subset of employee ID. However, employee ID and employee name together can determine employee name, where employee name is a subset of employee ID and name. Completely non-trivial. If a functional dependency X determines Y holds where X intersection Y is null, dependency is said to be completely non-trivial functional dependency. So in case of multi-valued dependency, this occurs when there are more than one independent multi-valued attributes in a table. For example, consider a bike manufacturing company which produces two colored bikes. One is black color and other one is white color. So these two colored bikes are manufactured in every model each year. Here is a relation. So if you look at the relation, the manufacturing year column and colors are independent of each other and they are dependent on the bike model. In this case, these two columns are said to be multi-valued dependent on bike model. We can represent this as bike model determines manufacturing year and color. Or we can represent bike model represent manufacturing year and bike model represents color. So this is example for multi-valued dependency. So more than one attribute is dependent on a single attribute means that particular dependency is called as multi-value dependency. Hope you understood till that. So now we will see about transitive dependency. So a functional dependency is said to be transitive if it is indirectly formed by two functional dependencies. For example, X determines Z. Determines Z as a transitive dependency if the following functional dependencies hold true. X determines Y and Y determines Z. If these two functional dependencies exist in a given relation, automatically X will determine Z. However, we should not have a functional dependency Y determines X. In that case, transitive dependency will become like X determines X, which is a self-determinant and trivial dependency. So when X determines Y, Y should not determine X, and Y should determine Z instead. So this is transitive dependency. This transitive dependency occurs in a relation of three or more attributes. If we have only two attributes, we cannot find transitive dependency. So transitive dependency holds true for relation with two or more attributes. Sorry, three or more attributes. This dependency helps us normalizing the database in third normal form. Hope you understood what is functional dependency and types of functional dependency. So in next video lecture, we will look at the axiom closure and minimal covers. Thank you.